Hi folks, I'm Chuck Black. We are doing Quokka walkthrough and we are in session number 14 of the walkthrough. The topic this time is going to be database. So if you've seen graphs like this, if you've seen lists of hosts or other type items like this, you may wonder, where does the data come from? How does it get into the database, etc. We've talked about how we used Sql Alchemy. We'll go into the details of how you initialize Sql Alchemy stuff. We will look at the code that actually makes queries and gets data from the database, whether it's one or multiple. We'll look at how you set data in the database, and as I scroll down here, we'll look at how we record things like host status, which is where those graphs come from, and the hourly summaries. That will be something we look at as well. And then when we're getting that data, we'll do interesting queries where we're actually not only filtering, but we're ordering the results and setting a limit on how much we get back. So that's what we will be talking about. Hopefully that sounds interesting to you. So without further ado, let's get started. So let's get started talking a little bit about our database usage in Quokka. Now, I don't have a ton of slides that go into detail about it. You can see here from this slide that Quokka does use Sql Alchemy to communicate with the database. So we're not doing things in a raw manner, but we're using this Sql Alchemy layer, which abstracts all of my SQL-ish stuff that I might be doing to the database via this Python package that does a quite good job of allowing me to define tables and to do queries and to write data, etc. I do have other slides that show a little bit about what's in the database. So clearly I have a devices table, I have a host table, I have a services table. Going a little bit deeper, when we're talking about gathering data, I keep device status. So there's going to be a status that has response time and availability over time. So we would call that time series data, and I have that for devices, for hosts, and for service. I don't have a slide, but I also have time series data that does hourly summaries. So it goes through and creates yet another table that is going to be a summarization, and I don't do it for devices currently, but I do it for hosts and for services. That gives us the nice graphs that you can see over the course of hours and days how things have been progressing. So those tables definitely do exist in the database. There's other stuff as well, but I don't have that many pictures. But this maybe gives you a good general idea. Now we're going to begin to dive into both. I'm going to look at the code, and we'll also look at the database through the command line, just so that you can see that it is indeed actually there and what it looks like from that perspective. So here's the code. This is all the code. I'll leave it highlighted for the moment, and we can walk through it in just a second. There's really, in fact, let me do this. There's really not a whole lot going on, except there's stuff hidden in here. First, I need to import Sql Alchemy from Flask Sql Alchemy. So I'm not using the raw or the general SQL Alchemy package, but I'm using the Flask SQL Alchemy package. It does things to integrate SQL Alchemy with Flask to make it easier. I've gone online and looked at discussions about, well, why should you use one versus the other? This is typical of things that you get. Some people arguing positives, giving positives and negatives, others saying, I don't see any benefits, yada, yada, yada. The bottom line for me is that it is definitely simpler to use Flask SQL Alchemy. So if you are wanting to make your life as simple as possible, then this may be the way to go, to use Flask SQL Alchemy. And that's what we did in Quokka. Now, what you need to do is you need to tell SQL Alchemy where is the database that we're going to be talking to. And so here you can see I have one line that's commented out. This is when I was using SQLite. If you recall, SQLite is the simple, almost trivial in-memory, it's not in-memory, but it's just a file database that is useful for doing testing and for getting up and running. So I do recommend it for that if you're just trying to get used to it. And when you move to a real live database like Postgres, there's a lot more involved. If you're just using SQLite, then basically you install it. And what this part right here in SQLite is referring to is that is referring to a file. So a lot of times you see things when you do specify what something is, you'll see 3 slashes. Like if you're getting at files using a browser or something like that, you'll often see the 3 slashes in specifying this for SQL Alchemy. What is important that you see here, the name of the database is actually a file name. It's going to be stored in temp/test.db, and you can actually see that file on your system if you're using SQLite. Now for Postgres, this is actually, there's not that extra slash. Notice up here there are 4 slashes. Down here there's 3. Make note of how many you're using there. This is actually the name of the database. So I installed Postgres, got it up and running, and automatically starting when I reboot my system. And I named my database that we're using Quokka. So I can refer to that, and we'll see that on the command line that my database is named Quokka, and this is what is pointing SQL Alchemy at it now. So this, let me just reiterate this. Here I'm using SQLite as my database engine, as it were. Here I'm using Postgres. I could also be using MySQL or some other type of SQL-based database if I wanted to. SQL Alchemy hides the nuances and the differences almost entirely from you or from me. So that's why we do this. And what are we doing here? Well, let's just take a moment and observe this. Here I'm saying app. Well, what's app? App is the thing that I created right here. It's my Flask application. So that's what I'm doing. I'm saying app.config. So that gives you an indication, okay, well, app is probably an object. And this is going to be, it looks like some piece of data in that app object. And if I am thinking about this in purely Python terms, then I would infer that, okay, I've seen square brackets and something in quotes before. This is probably the key, and that is indeed what it is, the SQL Alchemy database URI. That's what it's going to be setting. Once I've done that, then I can actually create my database by invoking this SQL Alchemy thing that we imported right here and passing in the parameter for initialization during the construction phase of my object. I'm passing in this application, and then SQL Alchemy will go off and do a billion things to set up the connectivity between my Python/Flask application and the database. So this is what gets my actual connection to the database up and going. Now, how does it know what's in the database and how I'm going to use it? Well, this is where I have defined Quokka, my Quokka models. And let me pull this up here. So Quokka.models, we're used to having imports be referring to an actual Python module that has stuff in it. But if I look here, Quokka models, that's an entire package. And what it's going to do is Python is going to go through here and it's going to import all of these modules within the models package. And what you can see, and what we've talked about, these things here that are not capitalized are probably just regular Python modules, but the ones that you see that are capitalized, you can infer this and I can confirm it. These are going to be SQL Alchemy classes. So they're going to be classes that I define that inherit from SQL Alchemy. We've pulled up host before, so I'll do this because it's nice and simple. I'm going to define this class. This is my class that I am creating myself called host. But when I put parentheses here, what am I doing? I'm saying I want host to inherit from db.model. And from Quokka, I'm importing db. What is db? Well, db is what I just created right there. So I am going to say db.model. That is something within SQL Alchemy. I want my host to inherit from that. That means all of the characteristics and even variables that are associated with this thing called db.model are going to be part of my host class, my host object that I create from this class, and I don't have to do anything about it. It's all magic that's done by Sql Alchemy in the background. If I were to go and look at all of these, whether it's events, you're going to see db.model device, db.model command, db.model. These are all tables in the database, and I am inheriting from them for every one of my Sql Alchemy classes. We've gone through this a little bit before, so I'm not going to belabor it, but I'm going to use that db thing that I'm importing, and I'm going to say, hey, here's a column in my class. This class is really going to be associated with a table. So these are columns in the SQL database. I'm going to have a column that is of type integer, and I'm going to call it ID. I'm going to have a column called name that's going to be text. I have IP address, MAC address. I'm keeping availability, which is going to be true or false. You can see that's a Boolean. Response time is going to be an integer value. And then I keep as text the actual last heard date. Now, just let me pause for a second on this. Those of you that are more advanced or have used this before might say, well, why aren't you using a date type of object in order to represent that? Because you can certainly do that, and that's available in your database stuff, and you can do a lot of stuff with it. And I agree, yes, that's 100% true. I wanted to keep everything as simple as possible for quokka, and that's why I'm just storing it as text. And then this is just the thing that's going to return when somebody just wants to say, hey, what is this thing? Or we're printing it in a log file. It's going to print out the name of the host. So the main thing, though, from a database standpoint, is we're inheriting from db.model, and this is going to be associated with a table. I'm going to go through all of the models, and then the last thing that I do is I do a create all. Now let's pause here for a second. When you see create all, you might think, oh, well, it's going to throw everything away and it's going to recreate everything. And that is not actually what is happening. I can't speak for how the name became what it is, but what this will do is it will basically create all of the associations between my models and the database. If the tables don't exist in the database, it will create them, and I will show you that. If they do exist, then it will just make sure that the linkage between my application and the database itself through SQL Alchemy is established. So that is the initialization part of connecting to our database. So now that we understand initialization of our connection to the database in the code and establishing communication so I can do SQL type stuff using SQL Alchemy, let's take a look at how we perform some of those functions. So what I have here is the hosts table. I'm using hosts again just because it's the simplest and cleanest to look at for now. This host table lists all the different hosts, and as you might imagine, this is basically going to the database and retrieving all of this information for me. And so how do I get that information? Not on the GUI side, but in the database side. And let's take a look at that. Now, looking at all of the hosts, as you might expect, would be via using this API method. So let's take a look at this code here and remind ourselves what's going on. Now, I have this module called APIs in which all of the APIs for getting access to the database live, so that I can talk in a Python manner via like get host and get all hosts and set hosts and pass in dictionaries and things of that nature. And I don't have to worry about any of the SQL Alchemy stuff, and it does the translation between my Python world and the SQL Alchemy world. Now you can probably see, maybe you will have noticed, if you look down here at the bottom right, this is the branch that I'm on. I've created a branch using Git called Refactor Model APIs, and I am in the process of moving things into different locations and different modules, and I'll probably create a folder or a package that has all of them in there. So I'm midway through there. I've moved all of the device model APIs out, but not the host ones, so they're still here in APIs. So that's where we are looking. We're looking in APIs in a little bit. My next task after I'm done recording this is to complete that process of moving out the host and service and maybe some of the worker APIs into their own Python module. But here we are, we're in APIs, and I'm looking at these three functions that I've created and that I use to get host information. The first one is get host, where I'm getting a single host. The second one, which is associated with this table that we were looking at, and that is get all hosts and then set hosts. So let's start with get all hosts. So how do we actually get access to the database and to the data in the database? Well, remember, we're using this thing called DB, which we are importing. And so all of our APIs have the ability to reference that database. What's the database? That's the thing that we created right here. This is my Sql Alchemy thing. So everything is going to go through that. So I say db.session. Why am I doing .session? Well, because imagine that we were running in a web application server like Flask, which we are. Every time somebody makes a request through the REST API, that creates a new session inside of Flask. This is important for issues like keeping track of requests and response, and especially for having multi-threading safety when you access the database, and especially when you're doing a database that maybe is not as advanced as Postgres. And consequently, the way that we reference things is we say db.session, and then we say, I want to do a query. And this is the function that we call, or method, we're going to call the query method. And what are we going to pass in? We are passing in, what is that data? So pause for a minute and think about that. The clue is that the first letter is capitalized. That is actually the class definition for host. If I was to do a control B on this, this takes me to the actual class definition. So when I did this class definition and I created it and I inherited stuff from Sql Alchemy, it created a whole bunch of infrastructure which makes it possible for me to do a database call. So it has all information, not all, but tons of information about the linkage between what I'm doing in Python and what I want to do with SQL to my database, all right? That's all I have to worry about that. You can see I'm doing the same thing. Up here I'm doing a query host, and right here I'm doing a query host. So you're going to see this pattern over and over again. So what am I getting out of the database? Well, this is probably the simplest thing to do. I'm calling the method all. That is going to return everything from the database. So basically when I look at this, it is returning all 34 hosts that I know about. All right. So it is going to return to me every single one of these hosts. I'm not filtering. I'm not doing anything to try to limit what I get back. Now, the next thing you need to look at here, and we talked about this a little bit before, these host objects are going to be in a list, but the objects themselves are SQL Alchemy objects. All right? They are not simple, trivial dictionaries containing only my information. They contain all of the extra SQL Alchemy information in them. I don't care about that, number one. Number two, I don't want my consumers, and when I say my consumers, I mean I'm providing this API and people are calling me. I don't want them have to know anything about SQL Alchemy. So what I want to do is I want to reduce each one of these host objects into just a simple dictionary, and that's what I do here. You might look at this and say, hey, I'll bet you could have used a list comprehension to do that and it would have been easier. You're probably absolutely right. I did it the old school way just for simplicity, and to help people to understand who might not understand otherwise. Maybe I'll consider making it a list comprehension in the future. But for right now, I iterate through all the host objects. And what I do for every host is I apply this function, get model as dictionary. What's that going to do? It's going to remove all of the things, and I think we looked at this, but I'm going to do Control B to go examine it. For everything for every item in this object that I'm passing in, I am going to ignore the things that start with an underscore. And if it doesn't start with an underscore and it's not itself a recursive call that I need to make, then I'm going to set the value. And what I'm going to end up with is a dictionary that has only the non-internal Sql Alchemy thing. So it has just my data. And when I'm done, I'm going to append that and I'm going to return it. Okay? That is fairly straightforward. Let me go through what happens when you get just one host. For getting one host, I'm going to be given the host identifier. So this is the ID that we have passed back when we returned information about hosts. So both the user interface and other functions that may want to call this need to know the host ID. And in fact, when we look at the user interface, if we were to look at the JavaScript code, when it gets this list for every one of these items in the list, it has the identifier. So it is able to have that unique identifier to uniquely access one of these things. And I'll show you in a minute when we might do that. What does this query look like? Well, the first thing is there's something called search. Now you look here, and if you're not familiar with that much with Python, you may be saying, is this some more of your fancy, maybe SQL Alchemy mumbo jumbo here? Absolutely not. All this is, what is this? This is a dictionary item, right? Key on the left, value on the right. So we're creating a dictionary called search. The first item in the dictionary has a key called ID, and the value associated with it is the host ID that was passed in. Now we're going to do a query. And remember, when we got to query host down here, all we did was say .all, get me all of them. But here, I'm not doing that. I'm saying, I want you to get me something from that database table based on this search criteria that I'm giving you. Now, I'm passing in, the search is actually a dictionary. And all you need to know right now is when you do this **, this is basically going to turn a dictionary into a bunch of parameters with keyword value pairs. So it's going to pass in a parameter called ID with the value of the host ID. If there were more items in the dictionary, this would translate into multiple parameters in this call to the filter by method. So basically, just looking at it from a pure English and cognitive standpoint, you could say, okay, well, this is looking and it wants to get just one item from the dictionary that matches this host identifier. And you're absolutely right. That's why Python can be sometimes pretty easy. And coding, actually, other languages are pretty similar to this. Now, the last thing we do is we tell it how many of these we want it to get. And the answer is we want you to get us one of these or none. So that means if it finds one, it will return it to us. If it doesn't find any, it will return to us this value none, which is what I'm checking for right here. What if there are more than one? Well, if there's more than one item in the table with the same host ID, guess what? That's going to throw an exception because that is an error of some type. And so that will actually look really ugly. I want that to never happen. If I'm writing production level code, I probably would want to have a try except to check for that exception and throw some better error than I'm doing right now, which is not an error at all. I'm not catching that error, I should say. It's just going to throw the exception and everything's going to blow up, which doesn't blow up all of Quokka. Quokka is going to still continue to run. All it means is that this one request that came in from the REST API is going to blow up, just so you know. It doesn't blow up the whole application. Anyway, So we're getting one of those. That's how this works, all right? Hopefully that makes sense. Let me go down to set host, and we'll talk about that next. Setting the host, what are we going to do? Well, somebody's going to pass us in this host. Now, this is made primarily to service requests from the discovery and the host monitoring task. And what we're going to get from them is going to be a host object, and it's going to include a name, and it's going to include an IP address. And so my search criteria in the database is not the host ID like it was here, because we haven't necessarily found this device yet. We are going to look it up based on name and IP address. And once again, we're going to assume that the combination of name and IP address are going to be unique. We're going to do this search, and we are going to return one or none. If we end up with more than one, that means that things, and I've never actually run into this, but it would mean that we have a situation where we have two hosts with the same IP address and the same name, and we wouldn't want that to happen. But this is the simple way that I did it for this training exercise. Now I'm going to get my host object back, and once again, it's going to either be one or none. I'm not going to go through this because we already did that previously. If it doesn't find the host object, guess what? We are going to create an entry in our table. Basically, we're adding a row to that table. And the way that we do that is we're going to say, this is our host class. We're going to create a host object. This is, remember, an Sql Alchemy object. And we're passing in the parameters, as a parameter, all of the information that we know about the host. So again, if I go here down to host, then it will have some or all of these particular items that you see right here. All right, so we're going to have this information probably mostly filled in. And what we're doing is we're creating a host object, which is going to be an SQL Alchemy object that has our host data in it. And all we need to do is we need to use our db.session, and we're going to say add this line to the table, add this row to the table. Now, if we find it, in other words, if host object exists, then what we're going to do for every parameter that is passed into us, for every thing that is present in host, for every field that's present in host, we are going to update this host object that we got back. So we're going to say, okay, if you're giving me an IP address, then I'm going to set it to the new IP address. Now, looking at this, I'm not sure I need to do the IP address because I searched for IP address, so maybe this is actually unnecessary. But we may include things like MAC address. We may include things like availability. That would certainly be potentially different than it was before. So if we're doing monitoring and the host goes away, as you see, if we look at this, you can see some of these availabilities have gone red. Then that would be something that changes. Response time, again, that's something that's going to change every time, well, potentially change every time we get access to it. So that, and then last heard, of course, is going to change. And if I look here at my last heard, for some of these, I haven't heard from this one since the 10th of February, and today I can tell you is the 23rd. This one right here, we heard at 7:22. As I recall, that's about when my wife went to work, left the house, so I suspect it's something that she took with her, whether that's her phone or something of that nature. These other things, I can tell you, it is like 9:07, so the ones that are green, you can see there are like 9:05, 9:05, 9:06, 9:06, etc. That is what I'm doing here. I'm updating those. And so in both cases, I have this host object that I've created here. I've added it here. All I've had to do is modify that actual object. This is just how SQL Alchemy works. And then what I do, I would have expected to do a db.session.update or something like that, but from what I've read, I don't need to do that. I just do a commit, and it will commit that data to the database. So here is a situation where I'm actually writing data to the database. All right, so that's some of the simpler getting of a single host, getting a multiple host, getting a setting of an item, a row in the table. And hopefully that has made some sense for how we do it with SQL Alchemy. Okay, I hear you say that's great, but what about for the cool stuff, things like this that I'm about to show you? What about this data? How do we record and retrieve this data? Well, that's what I'm going to show you right now. So this has a bunch of data. It has information about the host. Remember, last heard, MAC address, IP address, name. Those are things that are in the host table. And then this data right here, this is kept somewhere else. Those host status things that I showed you a little while ago. Where do we store that and how does that work? Well, let me show you. So I have two methods in my API file. One is record host status, and then the second one is record host hourly summaries. So these are pretty straightforward in terms of understanding what this is. Every time I do a polling or monitoring of a host, I'm going to store its status so I keep track of when I last heard it. That's the timestamp, whether it's available or not, and the response time. How do I set this? Well, I'm using a different table here. If you look here, this is my host status table. If I dive down into host status, you can see it only has a little bit of information, but it is totally different than the host table. Why is it different? Well, a host keeps one set of information for all time. It may update it, but it just has this information in it. My host status table is entirely different. It is going to continually be adding new lines to the table. So it is going to be adding availability and response time lines or rows to this table because it is it is time series data, not device data. Sorry, I read that. It is time series data. You keep recording. Every time you take a recording, you write it down into the database. And that is what we do here. That's why we're not doing any search to see if there's anything there. I suppose I could have checked to make sure that host ID exists, but I don't do that. All I do is I'm going to create this host status dictionary based on the information from the host. And I'm going to record the host ID, the timestamp of which is right now, so I generate that myself. And then I'm going to take the availability and response time out of this host dictionary that was sent to me. And what I'm going to then do is I'm going to do the same type of thing that I did before. I'm going to reference my class host status. I'm going to pass in my data. That's this thing you see that's been nicely highlighted by PyCharm for me. It has not only the host ID and timestamp, but also availability and response time. And then I'm going to add that line to the host status table in the database. So I keep adding lines. Every time I make a recording, I add it to the database and then I commit it. And so everything that you see here is a line that I have added. Every point here is data that I have added to the database. All right, and for response time, the summary, this is the hourly data. You can probably look at this and say, oh, look, Wednesday the 17th, I was running this, and then since I'm running on this system, I kind of didn't have this up and running all over from Wednesday evening until, what is that? Is that today? I think I started it going today, maybe, yeah, tonight, last night, something. So I haven't really been running it that much, but that's where my data comes from. This is where I store my status data and my summary data. So I'm going to record the summary data. I'm doing the same type of things, but I may have multiple summaries that I need to do. And so that's why I have this for loop in case I need to record multiple summaries, that it goes across multiple hours because I wasn't running it or whatever. Okay, so but I'm doing the same thing. If you look in here, I'm basically taking the same type of thing, except I'm using summary hour, availability, response time, summaries, and storing those to the database. And that is how this type of data gets stored. So you're probably saying to yourself, that's great, Chuck. I now see how this data gets recorded, but how does it get requested and returned, say, from the user interface? How does that work? Well, that's what we're going to look at next. What we're going to look at in the API call that gets called by the user interface is called getHostStatusData. And this is going to pass in the host ID and the number of data points. In other words, how many of these do you want me to get? And this is what it's going to do. So this is kind of SQL-y, and this is really where you see the value of a database. And so the database is going to allow me to do this. I'm making a query. Now, don't be alarmed. This is like it was all on one line. This parentheses, close parentheses here. This is just something that when I run, this is just a formatting issue. I could have put all of these things on one line, one after the other, but it would have obviously gone way off the end of the screen that you see here. And so the formatter that I'm using, this black formatter, actually organizes things in this way. So don't be alarmed or surprised by this parentheses here. This is just saying, this is just allowing me not to put a backslash at the end of every line here. I don't want to do backslashes. So putting parentheses around it allows me to avoid backslashes. So I'm doing db.session.query. Okay, that's the same as before. My table is host status. Yeah, that's where I've been storing the data. Now I'm going to say filter by, and here is my search string. So I'm specifying it completely explicitly and literally right here. I could have said search equals and then done a dictionary, host ID, etc. But I put it all together right here. So you've actually seen this before when we're getting one item. So that's what that is. What else is interesting that I can show you about databases? Well, I'm going to say, get me all of those things. I want you to order them by, so it's going to actually do sorting for me. And what is it going to do? It's going to sort them by descending order host status dot timestamp. So it's going to put things in descending order, all right, for host status dot timestamp. That's going to return things from the newest to the oldest. And so that is how I'm going to be returning this information. And the last thing that you need to see here is that I'm going to be putting a limit. So I don't want to get like a billion of them if there were a billion of them. I want to get just a certain number. And the number that I tend to pass in is like 24 or 30 or something like that. And once I've established all of that, then I say, get me all of them. And after that, I do my little thing that I could change into a list comprehension if I wanted to, where I'm going to change my model objects into dictionary objects, and I'm going to be able to use just regular Python dictionary stuff rather than having all of the extraneous SQL Alchemy stuff with me. And then I return the status data, and that is basically how we do it. So this is the interesting SQL Alchemy thing. You might want to get familiar with patterns such as that. Now I do the same thing over here for the summary data. So for the summary data, I'm going to a different table, but again, I'm making a query of my class. I'm filtering it by host identifier. I'm ordering by, in descending order, the host data summary.timestamp, and I'm limiting it to the number of timestamps. And the last thing is, this is kind of a utility function that I use for creating the summaries that you see above. And this one is interesting because I'm applying a different type of filter. I'm not trying to find something specifically, a specific column value equals something, but rather I'm asking it to do something special, which is if it starts with a particular hour. This is how, from my summaries task that runs in the background, I'm able to get all of the status data for a particular hour. And if I can get things for a particular hour, then I can do the summary data and calculate that and store it. Okay, so this is the interesting stuff. I think that this is kind of useful to understand. If you're interested in databases, you will end up doing stuff like this, and it's really helpful. Databases are extremely efficient and super fast at doing this sort of stuff, and it's stuff that we don't have to do because it's things that databases have evolved over the past 40 or 50 years to become very, very good at doing things of this nature. And this is how we use SQL Alchemy to perform that function. Now, the last thing that I want to do is show you a tiny bit of how to find your way around an SQL database. So we're outside the world of code and SQL Alchemy right now, and we're in the world of SQL databases. And what I'm going to show you is for Postgres alone. You can look up how to do it if you're using SQLite or if you're using a different database technology. So I'm going to say I'm going to do it in here, PSQL quokka, and this is going to allow me to get into the quokka database. Now, if I want to know what tables are there, and again, you can look up all of the different commands that you can do. I'm just going to show you some of the ones that I tend to do. \DT will give me a list of all of the tables that exist. So here's some friends that you will recognize. Host, we've been dealing with that. Host _ status. Remember how in SQL Alchemy we used camel case? Well, in SQL land, it's actually using snake case. So everything is small letters, so you get used to that. If I want to see what's in my database, I can say something like select. That is to say, I'm going to select from a particular table. So I'm going to select all columns from host, and it has autocomplete. And this is one of the weird things. You always put a semicolon at the end of your SQL statement. And there you can see I'm actually looking at all of the data in my hosts database. And I hit Q to get out of that. Now, if I wanted to see just the name and the IP address, I could say select name, IP _ address from host. And that shows me just a couple of columns. And why might we do that? The reason that we do that, if I say something like select from device, then you can see, whoa, that's too much. Do you see? This is the table, and it's wrapped around 2 3/4 or so lines worth. So I'm not going to fit this no matter how small I make my text. So if I'm only interested in the name and the IP address, then I could say something like select name, IP address, vendor, I don't even remember OS. I hope that's right. From device. And I was right. So here you can see I got, now there's only 3 rows in here, but I got the information that I was looking for. So that is a good thing for finding my way around in the database. I can do things like select count of all rows from host, and it will tell me that I have 34 rows. I can do the same thing, except from maybe more interesting, from host status, and I'll see, okay, well, I've got 2,572 rows in my host status. So I'm keeping about that much. I believe that I keep something like the last 4 hours worth of data or something of that nature. I have database maintenance task that runs in the background that keeps these things trimmed and small. Now I can also say delete, so I can say delete from host, and if I did that, it would delete everything from the host table. I'm not going to do that right now. It might have unpredictable effects. So let's get rid of that, and not get rid of it, but let's exit. Now what I'm going to do is I'm going to kill this, and then what I want to do, while it hopefully gracefully or not so gracefully exits all of the different background tasks, etc., what I'm going to do is I'm going to blow away the entire database. So this is like starting from scratch. Now you could go through and delete every table manually. You can also do a drop of the entire database. Now if I do a drop of the entire database and I start to run quokka, then quokka will fail. So I need to drop the database, and then I create the database. We'll look at it. The database is actually going to be empty, but as soon as I start quokka, it will build the tables that are necessary. So if I go back here, remember how in init we did this create all. So once I've deleted everything, all the tables, once I've deleted the entire database and then recreated it, it doesn't have any tables in it, but when we do a create all, it will create them, and then you'll see things start to get populated. So okay, so that has shut down. So I'm going to go to this thing here, and I'm going to do drop db quokka. This is a drastic measure. I'm going to lose all the data that I've had for the past months or whatever. My summaries are going to look a lot, they're going to be empty, but I'm going to drop it, and boom, my database is now done. If I started quokka, it would fail because it won't be able to find the quokka database. So instead I'm going to say create db quokka. So this is going to create my database called quokka. Now if I was to do psql quokka and go in here and display the tables, you'll see there aren't any tables, and that's perfectly okay. So what I'm going to do now is I'm going to go in here and I'm going to start quokka, cross my fingers, and hope that it runs successfully. I actually haven't done this. Aha. I'm going to have to figure out why this failed. Hang on a second. Okay, so we see that it is happy now, and I discovered my problem, and I don't know how I will edit this, but basically I had moved this code up above the definition of my views, and it turns out I needed to have this below my views, and I reminded myself of why that was true at one point, and I got to admit, I've forgotten why. So rather than spend some time figuring it out, I'm going to allow you to just hopefully trust me. It has to do with my definition of, I don't know if it's a circular definition or what, but I will figure that out. But when I move this back down here where it was originally, then now my quokka is actually running way more happily. So let's go here, and I wanted to show you this. I'm going to go back into here and say select star from host. So now you see I only have 7 rows. So I only have discovered 7 hosts. If I go to the user interface, you'll be able to confirm this. Where's my quokka? If I go to hosts, table in quokka, you can see, okay, well, I've got 1, 2, 3, 5. So I've got 7 of these devices that have been discovered. If I go to my status, you're going to see, well, I've only got like 1 status point, and I don't have anything in the summaries. So I have truly blown away my database. If you need to do that, you can definitely do that, and you will end up being able to start from scratch. Now, when we do software development, quite often we find that, yeah, we need to actually blow away the database and start over again because bad stuff has crept in. This is not production. This is in software development or R&D or just doing research or whatever it might be. So when you're just experimenting with stuff, you'll find, okay, if things aren't working, sometimes you have to reset the database. And that is sometimes the case. Now, in a real world situation, of course, you don't want that to ever be the case. Let's see if we've picked up some more hosts. Well, we picked up one more host, so we have 8 now. If I go down here and do this again, I can use the up key. You can see that I've got 8 of those. And if I was to do from host, select star from host status, we can see that, okay, so I've got a little bit of host status that's coming in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7. I didn't get anything from 6. So you can see that I'm beginning to build up my host status. Let me see if I can go to a host and have something a little bit more. So this is a little bit more interesting anyway. Availability, we have 2 data points. But hopefully you get the idea of a couple of things. Number one, you can blow away the database and things start from scratch all over again like I've done on my test system. So that can have some good things. In fact, we go in here to events. You can see there's only 3 events, so hardly anything has happened so far. Oh yeah, and I'm going and getting my configuration and stored it in the database, so that's kind of cool. And the other thing to learn is don't do things like moving this up here without fully understanding what you are doing just because you thought it would look good in the video that you are recording, because if you do, then you, like Chuck, that'd be me, end up looking quite stupid and foolish. So anyway, there it is. I'll probably leave that in to some degree. I'll speed it up when I was changing things around, but hopefully don't forget things that we talked about. I'll do a little quick review in just a second. Okay, so let's review what we talked about. We're using Sql Alchemy, specifically Flask SQL Alchemy, to talk to the database. We have tables for devices, host services, as well as other things. We also have device status, host status, service status for keeping time series data, and there's also hourly summaries. In the initialization process is where we declare Flask SQL Alchemy and we associate it with the actual database that we're going to be using, in this case Postgres, and we create a database object from SQL Alchemy. We learned that I needed to leave this code down here after the views. I did look into it. I do know where the problem occurs, and it's the opposite of how I would have expected it. So I'm going to leave it for now and just leave this code down here. When it comes to the APIs and how all of that works, we talked about doing searches and doing database.session.query, specifying the class that represents the table that we'll be looking at. You can do a filter by and pass in the search parameters and get one or none. If you want to get all of them, then you can do .all. And if you want to set for something like host, then you can search for it. And if you don't find it, then you can just create a brand new object with the host data that got passed in and do an add. Otherwise, you can update the host object that you found with the stuff that gets passed in, IP address, MAC address. The ones that will always get updated probably are availability and response time and last heard. So we talked about that. We then started to talk about the status data. And so we talked about how we record that status data in something like this. Of course, status data, we do a new entry every time. So we're not searching for something that already exists, but we're just creating a new item. So we're doing an add and then a commit. And hourly summaries, we have the mechanism for storing the hourly summary that's basically the same way, except we're referencing a different table with the host hourly summary. And lastly, how do you actually get that data? This is where it got a little bit interesting, because not only do we do a query on the table, but we're filtering by the host ID, but then we're doing this order by, and we're ordering by in descending order the timestamp, and then we're also limiting the number that we get. So we're limiting the number of data points. We do something like that for the host summary as well. So that's how we do it. That's a quick review. Hopefully that made sense to you and you know better how to do SQL Alchemy type database access, especially in a Flask environment. And you're prepared to do it either in Quokka or in your own application. Thanks for listening.